Go ahead and record just in case anybody needs some extra help here. So this very first one, we have the graph of the square root parent function, and they tell us, that it's y equals the square root of x. And then it's reflected across the x-axis. It's vertically stretched, so it's reflected. It's vertically stretched by a factor of 5, translated to the right 2 units, translated up 4 units, so a whole bunch of stuff, right? And then it asks us which notation can be used to represent the parameter changes on the square root parent function. So let's kind of chat about it. So with our parent function, starting off with the square root of x, if you reflect over x-axis, so if your original function was this, if you reflect it over the x-axis, let's think just one by one, right? Like, what would these changes look like? How would I show it? So a change of reflecting across x would be achieved by putting the negative in front of the equation, right? So a negative jumping in front of the square root, that's what gives us that reflection over the x-axis. The next thing it mentioned is vertically stretching. So do you need something to write with? So vertically stretching by a factor of 5. So if you have a vertical stretch, remember that is your A value, right? So that's like saying A is 5. And so that would be achieved by putting like a 5, right in front of the radicals. So that's what a vertical stretch of 5 would look like. If you translate to the right 2 units, remember that's going to be the inside or like under the radical part. That's like the h, right? So translating to the right, so think of that as the h. That's going to be opposite of what we would see, right? So the formula for our standard form is x minus h, so x minus 2, so right 2 would just have that minus 2 under our radical. And then lastly, going up 4 units, that's k. And so that would be like if I took the parent function and I added a plus 4 behind it. So k is always the true sign of what you see. Left, right, the h is the opposite sign. So to the right is positive, but it looks like we're saying minus, okay? Now what you need to do, because there's at least one like this on the test where they use this function notation where they write it like, you notice you don't see the square root anywhere, right? This notation is popular on the SAT and ACT and those type of tests because we are leaving it general enough to say, okay, the f could be any function. So any of these changes, these hold up for all, we've seen it. Cubic functions, parabolas, cube roots, absolute value, like any function, left, right, up, down, and then the vertical changing and the reflecting, all of that is achieved from the same components of your equation. So inside with x, that functions like the h. Outside the parentheses, away from the x, that feels like the k. In front of the f, that feels like our a value. And then, of course, if you throw a negative on it, we're talking about the reflections. So when you're looking at this, kind of a way to see it, and so that's just general form for any function. So you don't have to go this literal like on your test, but I would make sure that you're thinking about, okay, reflection, vertical stretch, right 2, up 4, what do those things look like as far as in my equation? And then when you come over here, process of elimination, like if you know it has a reflection, okay, we'll get rid of the ones that don't have a negative in front. Okay, so get rid of anything that doesn't lead with a negative. Then think about your signs, right? So let's say you get super confused on like your left-right stuff. Yes, you could graph your equation to test it, but you also know like k is always the true sign. So if we see a plus 4, I know that that's up 4 and it's outside of our parentheses. but this also has the right to that I'm looking for. So your answer choice for this one, your best answer is A. But you're just trying to look for each of those little things that are going to be described verbally. Okay, so there's a couple of problems like that where things are described verbally and you have to be able to find which equation would match up with that. But it's not too difficult. If you've been keeping up with all those transformations, it should feel kind of like a gimme, I think. But I know that it's weird because you don't see the square root. Just think it's just the general form. The H, K, and A are the same as far as how they move and what you'd be looking for. So questions on that one? Is there anything feeling confusing or tricky about that? Okay. Now the next one, we didn't do a lot of these, but there's no reason that we don't all get it right. We're going to be fine. So here we go. There's a lot. George. All right. So George, standing just outside his apartment building, throws a tennis ball upward from an initial height of 5 feet above ground level at an initial velocity of 25 feet per second. The height of the baseball in terms of time elapsed is a quadratic relationship. The generalized equation is this lovely little fella, f of x equals blah, 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 where v sub 0 is how we normally would say that. So, or yeah, this is your initial velocity, and h sub 0, just meaning subscript of 0, represents your initial height. So think of those as your two starting points. Now we have Sarah, who's on the 3rd floor balcony, 35 feet above the ground level, and she launches her drone helicopter that ascends at a constant rate of 5 feet a second, okay, and also 35 feet above ground level. We know that's going to be important. So typo, but if George throws the tennis ball at the same time Sarah begins to ascend flight with her helicopter, formulate a system of equations to determine at what elapsed times and heights the baseballs would probably strike the helicopter. Okay, so we're looking for a point of collision between the baseball getting thrown in the air, modeled by this formula, and Sarah's drone, modeled by an equation that we're going to have to create. So I'm going to start with our initial, or this first equation that they gave us. So f of x equals negative 4x squared plus v sub 0 x plus h sub 0. Now, this one is our equation that we're going to use for the baseball because it's a quadratic relationship. If you picture throwing a ball up, it's going to go up, hit some maximum point, and then it's going to come back down because of gravity, right? So if you just chunk it up, it's going to be some sort of a parabola shaped, it's going to go up with some initial velocity, and then it's going to come back down, okay? So what we're trying to do here is model that with our equation. So we're going to start with, the ball is 5 feet off of the ground. So we're told that, from a height of 5 feet above the ground, that's where the ball is going to be launched. So for our formula here, h sub 0, don't overthink it. What's your initial height? Well, that's that 5 feet. Okay, so h sub 0 is 5 feet. So we're going to plug that in to create our equation. But we also know our initial velocity. So it throws it up with an initial force of 25 feet per second. And so our velocity of 25 feet per second, and that's just, how hard the ball is being thrown up into the air. So that's going to go in the place of v sub 0 in our formula. So these problems can sound or feel maybe a little more intimidating, but especially on the ones where you're just setting it up, you just have to know what to plug in where. So, and a lot of it's common sense. So initial velocity, okay, they talked about that. That's v sub 0. And they even go on to tell you, v sub 0 to h sub 0, they give you those are those initial heights and velocities. So we know one of our equations is this. Okay, so that's the quadratic. That's for the tennis ball. Throw up, come back down. So just process of elimination, really on this one, you can already get to B as our best answer because our velocity is wrong on A and C. And then these two are switched. Our height and our velocity are messed up here. So process of elimination B. But let's just say that it wasn't that close. I just wanted to mention real quick about the second relationship. So Sarah's on her 3rd floor balcony, 35 feet above the ground level, and launches the drone. This constant rate, the only graph that has a constant rate is a linear one, okay? So if you've got a constant rate, that's slope, and that means it's linear. And so we need to be thinking y equals mx plus b. So at the algebra 2 level, they're not going to give you y equals mx plus b very often. They're just going to be like, oh, constant rate. They should know that's a line. So you just need to know that m, of course, is the slope. So your constant rate of change is 5, because it said 5 feet per second, so 5x. And then think about what the b represents. It's the y-intercept of your equation, but it also represents, if you think about it, it's like your starting point or your initial location in the context of real life stuff. So if we're talking about like when t equals 0 at the start of the problem, what's the location? That's the y-intercept. So your y-intercept and your initial height are going to be the same things here. So the fact that it was off of her 35-foot balcony, that's where she started the drone, 35 feet up. So her initial height or her B value being 35, if you're looking at that second equation, like where did that come from? That's how we're thinking of that. So Sarah with her drone, that's a linear relationship. George with the ball, that's a quadratic relationship. They're going to tell you that as far as with the quadratic, but they left you to do a little more thinking on what that linear relationship would be, okay? So don't let this shouldn't be, I know it's a lot of reading, a lot of words, but it's not that it's crazy hard. It's just knowing what to expect as far as plug in your values and then what your equation would look like there. Okay, questions on 2? Anything? No? All right, so I want y'all to think about this one for a second. What could you do on this one? So which equation corresponds to the values in this table? What could you do? Yeah, you could plug in your x and y and then see for that, see which makes a true equation, right? So you could plug in the x and y to see which equation is true. What's another way to do it? Because that'll work. We can do that. What else could you do? Yeah?
You could also just plug in the equations one by one and then turn them into a table in business.
Exactly. So we could graph each answer choice and check their table in Desmos. Okay. So those are probably the two, those would be your go-to options. So you can either spot check, plug in, one way to do it would be to plug in your, I would say maybe your easier numbers as far as your X and Y's, but I mean, you could start at the top, you could start at the bottom, it doesn't matter. But plugging in X and see, is that what you get for the Y? So for the first one, if you plug in X to be -3, -3 squared is 9 plus 2. 9 plus 2, not 7, so not going to work. But you could also graph it to see if, and then check the tables from there to see if that would work. So on this one, I'm a big fan of picking some of the easier numbers too. So if you plugged in, let's just, but we can stay with the -3. So I just want to remind y'all, when you square -3, let's see what we get, right? So we're saying we should get -7. So plugging in X and Y from my table, when you square -3, you get a 9. positive 9. But then this one had that extra negative in front. So is that going to be a true statement? So negative 9 plus 2, is that negative 7? Yes. And if you're not sure, of course, you can check it in Desmos. But this one should be our solution. Of course, you could continue to check, but you know, once you find it, hopefully you're good. You could keep checking points to make sure they all match. But I also wanted to show you in case you're like, I don't remember the table. If you click over, and I'm going to go to the full Desmos just because we'll need it in a little bit. So if you click over to Desmos and you type in y equals negative, and don't forget about your, like you can use this key or your keyboard x for x squared, and then plus 2. Whenever you do this to get the table, you can click on the gear and then that converts a table. And then it will give you some of these points. Now, when you check the ones that are in the table, you'll see we're missing 3, right? So we can, or negative 3. So you can check negative 3 and we do get negative 7. But just as you're like comparing, you know, what is in the table and the problem to the function, you should be able to see that they match. So that's a way to confirm that they match. If they didn't match, then you cross out that answer choice and move on to the next one. Okay, but that's either plug it in by hand or graph it and click the gear to see the table. Okay, so Desmos, maybe if you feel like you don't remember that, like maybe make a note, click gear to change to table if you need that. Okay, if you're like, I remember, then don't worry about it. Okay, so click the little gear icon to change it to table. And then from here, and I'll post, I don't have the key up yet online, but I'll get it added after we finish this today. So let's move to 4. Okay, so we're gonna solve this equation for all complex numbers. That means the imaginary, right? So you should expect that you're gonna have some imaginary numbers show up. So when you solve quadratic equations, you know it's quadratic because of the x squared. When you solve a quadratic equation, you need to get it equal to 0. So we're going to need to move that 25 over. And so right now it's being subtracted, so we're gonna need to add it. Now, you would try to factor this, but if you just kind of think about it in your head real quick, like what 2 numbers multiply to give you 25 but add to give you -6, like doesn't happen, okay? So to get, probably the easiest way to get our imaginary numbers here, you could either complete the square, so you could solve by completing the square, which I don't know that y'all want to do, or you could use the quadratic formula and simplify that down. So I'm almost leaning towards the quadratic formula as maybe our easiest, just because we can have that formula in front of us and it's not the whole plus a blank and, you know, rearrange your equations for that stuff. So for the quadratic formula, it's not hard, it's just long. So negative b plus minus the square root of b squared minus 4ac all divided by 2a gross. So remember our a, b, and c. Throwing those into this formula. -6 plus minus -6 squared minus 4ac all divided by 2a. So is it fun? No. But we can handle it. We've seen it before. Negative, negative. Negative, negative is just going to give us that plus square root plus minus square root of. So all of that, I'm just going to put all of that in Desmos, like the -6 squared, blah, blah, blah. So I'm going to click over to Desmos to just enter that in. I'm going to get rid of this. So I'm not even going to put the square root in there just yet. I'm just going to put what's under it. So remember, that's called the discriminant, right? So the discriminant is that part under the radical, and that shows us when we have, like, what types of solutions we'll have. So remember that with the discriminant, because that comes out negative, we know we're going to get imaginary numbers. Remember, we had a couple of problems on when we tested over this stuff that's all the whole like question asked, like, what type of solutions will you get? And we would know we would get imaginary or the complex numbers because of the negative. So under the radical for this one, I don't even know why I wrote it so gigantic, but -64 is what we would get here. And then that's divided by 2. So to deal with the negative, I'm going to just drop some of that so it looks less ugly. So remember that when you have the negative under the radical, that I can simplify that. The good news is you can take the square root of 64. So the square root of 64 is 8, but when you have a negative and you take the square root of it, we take the I out. So we put that little I, the imaginary, behind it. And that's our signal to know that this isn't a real number. Because we know if we try to take the square root of -64, our calculator is going to tell us, nope, can't do it. It's going to say non-real answer. Okay, so you can't take the square root of a negative, but I can take the square root of 64 and put the I behind it to show that it was imaginary. Now, to clean it up, to look for, to find our answer choice here, the only thing that really needs to happen is that everybody gets hit with that divided by 2. So technically, 2 is underneath both of these numbers. So I could rewrite that as this, and that's what that plus and minus is for. So 3 plus minus 4i, bringing us to answer choice D. Okay, so just be aware, you get that negative under there, drop the negative essentially. So like take the negative out. The negative is going to come out as the imaginary. Okay, that's the idea with the negatives. Because yes, if you try to type it in, it's going to give you an error message. That's okay. Okay, so questions on that one? And it's been a little while since we dealt with the I. What are y'all thinking on this one? So write the equation of a parabola that opens up and has a vertex of 4, -1, and is not vertically stretched or vertically compressed, and answer in this form. Y'all need help with that one? Yes?
Just plug it into Desmos.
Well, you could check each of these. Yeah, you absolutely could. You could graph each one of these options, and so that's a choice, right? So you could graph your answer choices. Another would be to recognize or just remember that the vertex, that's your H and K values. So, and if they're telling you that you're not vertically stretched or vertically compressed, that means that the A didn't change. So A is 1. So when it comes to writing your equation, if you just plug in, so if H is 4 and the K is a -1 and the A didn't change, then you're just looking at your choices to see which ones match is another option. So you can graph them and see which one is true, or you can connect that the vertex, that's HK. That's what the coordinates of the vertex always are. And so making that substitution for this one should be B. Okay, so not as scary as it might sound, just you need to know that H and K are the vertex coordinates. All right, this one needs to get multiplied out. So I'm gonna actually, just because it's been a lot of me talking and I want you guys to try something, I'm gonna have you guys try this one. Remember that I squared is equal to -1. Okay, so that's kind of a little fact we want to remember. But you just need to multiply this out. So you're either going to FOIL it or the box, all right? I don't care which, but you need to multiply these two things together and then write the product in standard form. So take a second and you guys do it. I'm gonna come over here and I'm gonna try it as well, and then we will compare answers in a second. Okay, so we'll work together and check each other. So I'm gonna freeze this one. I'm gonna pause it on the video for a second. Okay, so I know my folks that are joining us today for the first time, you might be feeling a little extra lost, so just write it all down and we can talk it through later as needed, okay? But you gotta, let's just try to have our game faces on, okay? So number seven, find the solution to the following square root equation. So the first thing you need to remind ourselves about, just like with the 1/3 we saw recently, is that a power of 1/2 is the same thing as a square root. Okay, so when you see that, I know that it didn't print like maybe super great, but this 9x minus 11 to the 1/2, that's the same thing as writing that as the square root of 9x minus 11, and that's equal to x plus 1. Okay, so of course, right? Of course, they had to go and put in a problem like this where we need to solve for x. So usually when you solve for x, we're like, hey, get the radical by itself. That's the first step. Get the radical alone. And then we would square both sides to clear the radical. Well, we're still going to do that. But this was one of the ones that sucks because there's an x on the other side. And so when I go to clear this radical by squaring both sides, I then have to multiply this side out. Okay, so my first step, we want to get the radical alone. Then we want to square both sides. But this situation was the situation that was worst case, okay? And of course, they had to pick the worst case. They couldn't give us the easy ones. So squaring and square rooting are opposites. So taking the square root and squaring, those two things cancel out, which is great on the left. Like the left, love and life over here on the left side. The right side, not love and life quite as much. Because on the right side, remember what this is saying. This is saying x plus 1 times x plus 1. So don't make that rookie mistake and say this is x squared plus 1 squared. That's not what this is saying. This is FOIL. This is multiply it all out. This is first, outer, inner, last. So when you multiply with FOIL, first times first, x times x gives us x squared. Outer, the stuff on the outside, x times 1. It's positive 1x. I in FOIL for inner, 1 times x, again, 1x. You can write the 1 or you don't have to, it's up to you. 1 times 1 is 1, not 2. Careful, don't add, you're multiplying. 1 times 1 is 1. When you multiply these out, remember your middle terms come together. So x squared doesn't have any friends, but the x's are like terms. So you've got 1 plus 1 gives you 2 in the middle. And then the constant that also doesn't have any like terms. That plus 1 doesn't have any friends. So now that is going to be what my equation is equal to. X squared plus 2x plus 1, okay? So I had to FOIL this out to get what my equation should be equal to on the right. So that's the reason that this is the worst case scenario, because when you square, you got to do all that extra work. From here, we have to actually get our equation equal to 0, because to finish this up, anytime you have an x squared and an x, you're either going to need to solve by factoring, solve by quadratic formula, like one of those methods, completing the square, one of those methods for solving these equations is going to be needed. So in order to do that, like to finish it, you need your equation equal to 0. Okay, so we had to get our equation equal to 0. So what that would look like is I always just move whatever side has less stuff on it, honestly. So the left side has slightly fewer terms. So I'm going to try to cancel both of those out by doing the opposite. So 9, I want to make it go to 0. So I'm going to subtract the 9x, and the negative 11, I want to make that go to 0. So I'm going to add 11. Cancels, cancels on the left, giving us that sought after 0 that we were trying to get. There wasn't any other x squared stuff, so that stays the same. It's just going to come down. 2 minus 9. Do that in the calculator if you need to. No shame, right? 2 minus 9 is negative 7. 1 plus 11 is 12. And then it's factor time. So this one has all of the things in it, okay? So after you get your equation equal to 0, now we will factor to solve for x. And I'd write all these little notes because I'm telling you, we purposefully pick problems that align really nicely to the test. So if you've got all your little steps on here, it should just be a matter of following it when you take your test next class. So, and you've done all this before. It's just been a little while, right? It's been a crazy year. Everything feels like 10 years ago that you've done all this. Even though it was only a couple weeks ago, it feels like forever. So factor to solve for x. So remember when you factor, you're looking for what two numbers multiply to give you, like technically it's a times c, right? So you're looking for what multiplies to give you 12, but adds to give you negative 7. Okay, so those are the two numbers. You're looking for how do I multiply to get 12, but add to get negative 7. So to get 12, let's think about how you can get 12. 1 and 12, right? Multiplying, of course. 2 and 6. 3 and 4. So those are the ways that we multiply to get 12. Whenever you're looking for a positive number, remember that when this number is positive, we know that we're going to have the same sign, right? So we know because this is positive, we need the same sign on both of our numbers. Because I'm going to say AC is positive. So when that number is positive, it's either plus plus or minus minus. Well, how do we want to come out when we add? Well, we want negative. So I know I'm going to need 2 negative numbers when I add them together. So everybody's got to be negative. In your heads, you're probably already seeing which one's going to give you 7. But you could check them all if you didn't see it. So if you add these all up, you're looking for which ones add to negative 7. So add to the middle, multiply to the back. And the hardest part's the signs. And so once you find your signs, so a negative times a negative is a positive, but a negative plus a negative is a negative. So this is perfect. And then you have that last step of set factors equal to 0 to solve. And so it's like we made 2 little baby equations out of it. So like each one of these factors gets its own equal 0. So now we got 2 little equations. Solving for x, you get x to be 3 and x to be 4. All right. Now technically with these, we need to check, you would in a perfect world, we check them, plug them in, make sure that we got our solutions down correctly. And so we'll make a note just to plug into check, we'll just say plug into check answers. Just in case you have any extraneous, right? So when you plug them in, you should be plugging in just to see like, do they make a true statement? Okay, so if you did 9 times 3 and then minus 11, take the square root of that. Does that give you, you know, your solution here? So checking those would be kind of your last step. But this is already so much that we're gonna roll. So that's a terrible problem, right? Now this one we've done recently, so I'm kind of not planning on going over these. I'll post the, you know, I'm gonna have you guys work on them. But I'm gonna let y'all, like y'all try 8, 9. I'm gonna go ahead and like, let's just chat about 10 real quick. Solve the system. Okay, so this problem without answer choices makes it seem like the one on the test is going to be like crazy hard. So actually the one on the test is more about, it gives you, it's like written out in words, and it kind of like walks you through the process of like looking at the graph and then identifying like what the answer would be, and like you identify like which statement is true about the graph. So if you work this by hand, it turns into a pretty big problem. Not that we can't do it, but it's a pretty big problem. But when you graph it with the full featured Desmos, the nice thing about that version of Desmos is that you can put these two equations like straight into Desmos and graph it. So like exactly the way they're written. You don't even have to rearrange them. So I'm going to go ahead and put in negative x, let's see, squared plus 2x. And I think I'm not lying about this. And maybe they might want you to solve it for a while. I'll have to find out. I haven't. No, I was going to say, I think it takes it in any form, which is so crazy to me. A couple years ago, like y'all might have been part of the group that they let like use this version on the STAR test, and then they took that away like the next year because like some people's scores, like some schools had like crazy high scores, and it was just because like Desmos would graph anything. Now like everything has to be solved for y. It's pretty crazy. Okay, so what you're going to be looking for is your points of intersection, because even, you know, when you think about solutions to systems of equations, when it was linear, you just looked for that point where the lines crossed each other. This is a quadratic and a line meet. So there's two solutions here. But you're just going to be looking, I think that like you're just selecting like which of the answers like is one of the solutions. I promise it's not difficult. It's just read through and see which of them is a true statement about like the solution. But I just want you to make the connection that, and I'm going to do like a rough sketch of this on my paper. And I would advise y'all to maybe do the same. But I'm just gonna, you know, just so you know, like when you go back and look at it again, what you were looking for. So you're looking for where the quadratic and the line meet each other. And so this is going to be, I'm going to mark that at 4, -7, and then -3, 0. And just draw a line through there. Okay, and so then on my paper, this is all I'm writing. And so just kind of identifying that these are your solution points, okay? So the points of intersection are your solutions, okay? And so they can identify either one of these points. They might only, you know, I think on the test that they just picked like one of the two. They won't both be on there. But that's where your answers are coming from, like where the line crosses the parabola. And because it's a parabola in this, you know, when the line passes through it, you get 2 solutions out of it. So you're just going to be looking for one of them. But I have no desire to make us go through that by hand. Like, what's the point, right? Just to stress us out, like, no, we don't need to do that. So let's just focus on like using our technology. Just remember that this is going to be a graph one. Okay, so we'll go into that Desmos, we'll graph these little guys and look for where that line crosses the parabola. Okay, so yeah, by hand it's kind of gross, but with a calculator, it's not so terrible. Any questions on that one? Look for where they cross. Okay, so then this one's going to be kind of the same type of idea. This one's going to give you, like, say you have a systems of equations, and then it's going to ask you, or it tells you like what the solutions are, and then there's like answer choices that are like, which of these is a reasonable, way to, confirm or check your answers. So I just want us to think about like graphing, what did you just do? So if you're trying to see how you could figure out, are these the solutions using graphing, you would want to graph each line. So check the locations where the line intersects the parabola. Okay, so if we wanted to make sure that these were the answers to this solution, or to the systems of equations, we could graph these two in Desmos the way we just did on the other one, and just make sure that our lines are going to cross at these spots. So just like the last one, we had 2 points of intersection. Here's another, problem where you have 2 points of intersection. So are our lines crossing at these points? So visually, graphically, that's what you're checking for. You're looking for where do the lines cross. Now, for a table, so let's say that, you went to graph these. And so if we were looking at, and we could go ahead and switch it out. So if I switch this one out and type in x squared minus x equals y minus 5. And then for the second one, I have 2x equals 2y minus 16. So graphically, right, like where they cross. So that's the first one we talked about. Another thing we could do is if we were, or maybe this one's not going to let me change them to tables. So if you had a table, I don't know why it does on some of them. I guess because I don't have it in y equals form. Sometimes Desmos is picky about like when it'll give you a table. So from a table, you would want to see that you have the like that your x and y coordinates are like going to match each other if you were looking at the table. So from a table of values, we want to see same y values for the same x values. And so what that would mean is that our graphs are in the same spot. It's just not the visual representation. So, but for a table, you just want to see same y values for the same x values, so you know these points exist for both of our equations. And then substitution, what we mean by that is it's pretty much like what we did on the very first page, like with this stuff. So if you were to take your solutions, right? If you were to actually take the coordinates, so we took like these answers, and so for x and y, and then again for x and y, we kind of think x1, y1, x2, y2. So for substitution, if you plug in your solutions, they should make equation true, right? So when you plug in your equation, like you plug in your x's and y's into both of your equations, what you should get are true statements. It might come out to be like 6 equals 6 and 2 equals 2. But the key is that they would satisfy the equation. So if you plugged in x and y, you shouldn't get like 1 equals 7. Like that would mean that that's not a solution. So substitution is just what it sounds like. Plug in your values and see which ones come out to be true. Okay. Let's see what else we got here. I'm just kind of trying to jump around and see what y'all can look at. For writing the equation of the quadratic, you're going to have answer choices for something like this, but just a friendly reminder. Sorry, that H looks a little funky. So identify your vertex, right? Because that's your H and K. So start with that vertex and then make sure that you know those coordinates. Hey, what's that? So for this one, we just want to make that ordered pair. Like this is going to be 3, 1.
I think it's switch house.
So you're in third. Weren't you in third before?
Huh?
Aren't you in third? I thought you were in third already. We're in second right now.
Yeah, I was just in my second.
And he told you to come here?
Yeah.
Why?
Um,
Doesn't
That's
start till
weird.
1:10. Okay.
No.
Well, did your health period switch? Did you have health second before?
No.
That's what happened. So you're technically, yeah, your lunch on this day got switched because your lunch is connected to your second period. And so when they change your schedule, like you're still third for me, but your second period switched.
Oh, so like I have lunch right now?
You have lunch right now. And so then when lunch finishes, you're gonna come here for third like that. Okay.
Oh, okay.
Yeah. So they love and say you're still in third, but yeah, I didn't realize your second switched. All right, sweetie. Yep. See you in a little bit. Okay. So you're just gonna plug in your H and K. And as far as the A value, like there's a way we can calculate it, but I'm just gonna cheat and say that you don't need it on your test, so we're not gonna spend time like worrying about calculating it. Okay. So the only thing you really need to be able to do is identify H and K and plug it in. Why complicate things? Okay. I did want to hit this one because I think it sounds scary. Okay. Based on the cube root, which statement is true about f of x and the inverse? So remember, this notation means inverse. So, okay, one thing you can do is find the inverse, then graph both. And I would honestly pretty much recommend that you do that just in case. I know some, I mean, you can get rid of some answer choices, like the first one. The x-intercept of f of x is at 3 and the y-intercept. Okay, well, I would almost have to like graph at least one of them to see if that's true, right? So like, let me check the graph. But this next one, the domain is restricted to blah, blah, blah. Okay, we talked about cube root and inverse. It's inverse, which is the cubic function. These have domains of all real numbers. So there is no domain restriction. So like we know we can kick that out because that doesn't even make sense. F of x has a 180-degree rotational symmetry about this point. Okay, you could probably guess, you know, rotation and symmetry and 180 degrees. But I would also venture to say if we've never even like said the words rotational symmetry in this class, like that's not the answer. Okay. And so then the other one is about where they intersect. And so, you know, you could graph like this first one by itself just to see if like A is true. And if A was true, then like you're like, oh, I better check, you know, to make sure that this is also true. The only thing is that, you know, maybe we're lazy to calculate this part of it. I don't know. But, you know, we could graph this first part. I did want to show you guys, you know, one more time about the cube root. So remember that when you're graphing f of x and y are the same thing. But if you want the cube root, you can either do the power of 1/3 or in the miscellaneous functions over here, that's when this end root comes up. So that's how we can do that third, the third root, and then x plus 2, plus 2, and then plus 4. And so just taking a peek at this one, it said that this one had an x-intercept of 3 as far as answer choice A. And so I can see pretty clearly that this does not have an x-intercept at 3. And so process of elimination, I could go ahead and like pick this one out because that's not true. At that point, you're counting on this being true without actually checking it. So, I mean, it depends on how confident you feel. I will say don't just automatically choose this one because it's, an option on the test. I'm not guaranteeing that it's the intersection. It could be the intercept one, for example. So it could be one about the domain or range or something, but just, wanting you to think about getting your inverse. But we did this really recently. So for the inverse, I'm not going to go through that. I'll post it, but I'm not going to go through that whole group. I'll let y'all try that one. We've done this one recently as well. Write the equation for a cube root function with some of these transformations. And so I'm just going to give you this and then let y'all try to do that. Oops, H, my bad. Why I keep wanting to write like random numbers in place of letters today. It's a problem. Okay, so that's your parent function. And so thinking about like the effects of A, H, and K. The last one I'm going to do with you guys before, I'll post the key, but the last one we'll do together, just talking about 15. This should just be a Desmos. And so if you go to the full feature Desmos, not the star one, so the one that has the little black banner at the top, it'll do that inequality stuff for us, right? So we can go in and just take this out. And y, you see your inequalities are here, right? So y is greater than negative, what was that, 2, and then parenthesis x plus 4, close parenthesis, squared, and then plus 5. And so, you are essentially, it's multiple choice, right? So you're just finding the one that's going to match this, but that we should expect this. It's a dashed line. So you want to look for that. Make sure you're looking for the one that has the dashed line. You also want to make sure that you're looking for the one that's shaded above, right? Because y greater than, go to the vertex and go up for greater than. And so I'm just gonna, kind of approximate this. Its vertex is at -4, 5. And then it's just, I'm gonna just show that I've got a dashed line, and then I'm gonna shade above. Okay, so I'm just gonna rough sketch it. So yeah, like we could do it by hand and we could solve and test points and stuff, but why? But why? So the last 20 minutes of class, I want you guys to spend just trying to answer the ones that we didn't do. I'm gonna finish it real quick and post the key in Schoology. And then anything from there, just make sure you have your review with you next class and then ask questions today if you are finding yourself